Okay, so the last two lectures we were discussing how to develop flood fragilities. We did it for 2D and we did it for 3D fragilities. Do you guys remember what parameters when it's 2D fragilities? What is the intensity parameters? It's the flood depths. And when we did the 3D, what was the intensity parameters?
Flood depth and duration.
Flood depths and flood duration. All right, so the thing is, we did this only for one archetype. We did it only for two-story residential building archetype. So, and this is the one for your homework. You guys have all the data, right? I uploaded the component, and also you have the videos. All what you have to do, you go through the videos line by line, trying to write them. There's some lines that you can escape, but there's some that are very important you cannot escape. Try to go through them one by one and write them and run them, okay? So that you can, at the end, you can get the fragilities. So at this point, I'm gonna assume that we have done this for all the archetypes that we have, like for archetype 1, 2, 3, up to the 15. And the thing is, the final output that we had, if you guys from last time, if you remember, the final output was the curve. And to draw the curve, you need to have points on these curves. And if you guys remember, the fragility is something like this. Depth on the x-axis and the probability, let's say the exceedance probability on the y-axis, and let's say damage is state 0, damage is state 0, something like this. So we had the flood depths each 0.01, like every 1 centimeter you have a value. So at the end of the day, you are gonna have a table D and the probability of exceedance from 0, 0.01, 0.02, and then you will go all the way down until 10 meters, right? So you are gonna have, I don't know, around a 1,000 value for the depth and 1,000 value for the exceedance probability, so that you can draw this. The thing is, we need the analysts not to deal with all these big numbers. So we did something called fitting, log normal fitting. And the fitting, these actually, the values was like points. Let's say we talked about the raw fragility without any fitting. It was something, let's say, was something like this. That was this 1,000 number. Then we did log normal fitting. What is log normal fitting? This function, it's a CDF function. CDF means cumulative distribution function. That means it's like, if you guys remember, when we have the normal distribution was something like this, but when we draw the cumulative, it was something like this, go from 0 up to 1. So we basically plus all these areas, and the area under this curve is 1, which is, if you guys remember from what we have done, this is 1. That's what is CDF. It's the same thing. Cumulative, it goes from 0 and it goes all the way up to 1. And for this fragilities, it has something like, I can condense all these numbers and do the log CDF. I mean, I do log normal fitting, like I can call this log normal fitting. You basically fit this black line into a line that has two parameters. These parameters are lambda and xc. And if you know lambda and xc, you can go to any software, statistical software like MATLAB, and give MATLAB lambda and xc and can draw this curve for you. So rather than I use all these numbers, I'm gonna use just two numbers. Okay, but this is only for one curve. But the thing is, when I have fragility, I have one for damage of state 0, one for damage of state 2, 3, 4, 5. So for 5 damage states, you are gonna need a lambda and xc for this one, lambda and xc for this one, lambda and xc for this one, for all of them. And actually, that's what the publications do. For publications, when you publish, you will have to show what is your lambda and xc for each one of these fragility curves. And let's say I'm gonna go and check the wind fragilities that was, let's look at the flood fragility. Here. Yeah, here, see? So that's actually the final results from the 15 building archetypes. I did like all the work that I have done over the last 2 lectures was just to getting one of these lines. One of these lines, just to get the fragility parameters. And I have to repeat them all the same for the 15. But at the end, I have the lambda XC, the log normal CDF for damage state 0, damage state 1, 2, 3, and 4. So I can use these numbers to generate these curves. I don't have to have these numbers again. However, these numbers are the one that more accurate, the raw one, because that's the actual one that we got. However, for the analysis purposes, it's better to use something that is that has a parameters like lambda and xc. All right, I'm gonna teach you today how from just 2 numbers to generate these curves. So we're gonna see how we can do the reverse function. Like rather than going through the whole process to get these functions, I'm gonna show you how can I use these numbers, use these 2 numbers to develop a curve. That's the my mission number 1 for today. But I want you to look at this. I have in damage state 0, I have only archetype F1 and F3 that has numbers, and the other archetype doesn't have. That's because archetype 1 and 3 are special archetypes. So, and that's actually only special for this case. Like, I mean, like for wind archetypes, they might be different. So I'm gonna tell you why the other ones doesn't have one. So the way when I develop these fragilities, I have archetypes that was on a crawl space foundation. I mean, like they were elevated from the ground, and another one that was on a slab on grade foundations. All these archetypes, F1 and F4, 5, up to F15, they were all on a slab on grade foundation, except archetype 1 and archetype 3, they were on a crawl space foundation. Archetype 1 is 1-story building on a crawl space foundation, and F3 is a 2-story building on a crawl space foundation. Do you guys know what a crawl space foundation is? It is like when it's not slab on grade, like the slab is not on the ground. The thing is, the crawl space foundation, you have to have a wood posts or piles or something, and the foundation is elevated from the ground, and there is a crawl space under the foundation. People sometimes use it to put the mechanical systems for the AC. They use it for storage, whatever they can put there. Okay, so how crawl space foundation made these 2 archetypes like unique to have damage state 0. The thing is, when you have a crawl space foundation, I assume that I have ducts in this crawl space foundation. I have some components there. So, and these components are below the verticifloor elevation, so they are damageable components. So since I have damageable components below the verticifloor elevation, I put them in a damage state 0, which is called insignificant damage. But the other archetypes doesn't have components below the verticifloor elevation because they started from the ground. So basically, the verticifloor elevation is almost or close to the ground elevation. So they start right away from slight damage, which is damage state 1. Did you guys get that? So I'm just like showing you why some archetypes have, you know, if you have elevated building, like do you guys see the buildings on the coast? They're usually elevated by 1 story. There's like piles, and then they start, the first story is like at 10 feet high. So for this archetype, I would assume they will have damage state 0. Why? Because there's at least 1 room downstairs that they can put some components and might get damaged. So that's one way to think about it. Anyway, so we have 2 special archetypes that have damage state 0. However, in some applications, I might neglect this damage state. Why? Because the amount of components below the verticifloor elevation is like, I don't know, 2% of the building replacement value. Like let's say a building is a $1 million. So 2% is like how much? That's like 20,000. So maybe you overlook these components if it's gonna complicate your analysis. And that's based on my assumption. Some people, they don't put anything below the first floor elevation. They put their attic, they put like the system, the furnace, the AC in their attic, and they use completely different system. Yeah, so that's something that I thought that you might need to know. So that's for these components. So let's assume for now, the two lectures, the last two lectures we got these numbers, and we did this for all the archetypes. So right now, we have a portfolio of building archetypes that ready to do vulnerability analysis for community level. Why? Because these archetypes, like this one, it's an office building, I guess. You have some schools, hospitals, gas stations, businesses, residential building. So basically, I'm gonna look at the community and see each building, what is the use of it? Oh, this is a gas station, take archetype 5. This is a residential 2-story building, take archetype 3. This is this and that. I assign each one of these archetypes to each building within the community. Do you guys got that? Why we have this portfolio? Okay, so our mission right now, and that's actually what you are gonna do for your project, like the first task in your project, I'm gonna upload the project description, is to develop the fragility for archetype 3. That's the first task, the last 2 lectures, okay? The second task is to do what I'm gonna do right now, to do community level analysis. I'm gonna give you this table, or you can write this table on Excel sheet, okay? And then I'm gonna give you a community, or you can grab the community from the sources that I'm gonna give it to you right now. And then you are gonna do vulnerability analysis for every building, for each building in this community, okay? So let's see how we can do this. First, we need a community, right? We need data about the community. What kind of data that I need about the community so I can do vulnerability analysis?
Occupancy type. Occupancy type.
Community type?
Occupancy.
Occupancy type? Why?
To define which archetype can I select between them.
So, but the archetype does only need the occupancy or need other parameters?
Other parameters.
Like what? Do you guys need
foundation type?
Foundation type.
Number of stories.
Number of stories. We need a bunch of information so that we can assign each one of these archetypes. Like we need, do you guys remember these archetypes have some building that are 1 story, some are 2 stories. Some buildings on a slab and grade foundation, the thing that we were talking about, and on a crawl space foundation. How can I distinguish if the building is F1 or F2? F1 and F2 are similar, but one of them is on a crawl space foundation, like the foundation is here, and one of them is a slab on grade. The slab is on the grade. So we need to know all these information. And also we need something very, very important. It's called the versus the floor elevation. So that's also something that we need. Sometimes this is not given directly, so we have to find a way around it so that we can have the best engineering assumption about it. Like, okay, you will rarely find a database that has building versus floor elevation, but we can do something like the foundation type, if you know it. Maybe if it's a crawl space foundation, we can make a best judgment about how elevated is this foundation on the ground. Usually 3 to 5 foot. If it's a slab and grade foundation, usually if the ground is here, you only take 1 step and you are inside the building. So maybe 1 foot from the ground. So if it's elevated building, 1 story elevated, usually the 1 story is around 10 foot. So we can make an assumption about it. And also there's some database that also give you the foundation height. So basically you sum the foundation height with the ground elevation to get the versus floor elevation. So that's one way to do it. Do you guys remember the data that I told you that has a lot of information about the buildings? We talked about many data. First, you can access. Let's say that you are an engineer, a catastrophe modeler, and somebody or a company approaches you. I want you to do risk analysis for Santa Cruz County, California, or San Jose, California, or Galveston, Texas, or whatever county that you're gonna. So first, you need to get data about this county. So what I would do, I'll go to Google and search this county. Like for example, I'm gonna today search how can I want to do analysis for Santa Cruz County. So I'm gonna go to Google, and not Santa Cruz, let's say Nueces County, buildings, GIS, I have to go GIS, layer for buildings, or shapefile for buildings. So you'll find something called Nueces County Data Web Map. But the thing is, if it's map, I will not be able to get anything, because I believe it's just only for visualization. You will not get that much data out of this map. So maybe I will have to look for something else. There's counties that provide parcel data, but I believe this is like a vendor that you have to buy the data from. Like if you go inside, it's gonna ask you to purchase the data. Yeah, here, see? It says that you have to pay, that's gonna be plus $100, some of them are $500, so, yeah, so you might, the thing is, we're not gonna buy the data, absolutely, but I mean, like, there's sources, they sell the data. And by the way, back in the days when I cannot find buildings data, so what I would do, there is something that's called the Microsoft Buildings Footprint. So for Microsoft Building Footprints, they provide you with the footprint of the building, but doesn't have any data, if you guys remember. And I download the parcel data. If you guys remember, the parcel and the building is always inside the parcel. So I overlay all the data of the parcel to the building. I give the data of each parcel to the building attached to it. Okay, so that's one way to do it. It has some limitations. Some parcels has multiple buildings. Like if you have a hospital, big hospital that has 5-6 buildings, and it's on one parcel. So like let's say a hospital has 5 buildings. One is like 20 story, and one is 2 story, and one is 10 stories. So the parcel has only one data. So if the parcel has that this building is 20 story, so all the buildings are gonna get the 20 story characteristics. So that's the limitation. But if it's only one building on the parcel, you will not have that much issues. And by the way, I believe the National Structure Inventory data is parcel-based data. They basically give the parcel information to the building. All right, so I'm gonna tell you what data that I'm using. I told you that I use the National Structure Inventory, so I put in Google NSI data, and then I will access Army, because it's from the Army Corps of Engineers. And Nueces County is in Texas, so I click on Texas, and I download the data. When you download the data, it's gonna show up, because I did this before I come to the class to save some time. Here, it's gonna be like 1 gigabyte folder, and it has here the number of the state, and says NSI data, the last updated in 2022. If the county that you are dealing with in Florida, so you click on Florida and download the data. You download the data for the entire state, so you cannot download by county, which is, I believe, it's not that good, because there's a lot of data I'm not gonna use, and the thing is, to load the shapefile of a 10 million building in Texas at the one folder is really heavy, okay? So, but anyway, that's what we have for now. So I download the data, and then once you download this data, like let's go to the data. The data is in format that's called GeoPackage, like this, and it's zip. So GBKG, and this GeoPackage you have to unzip it, and it's gonna give you one folder like this. It's not a shapefile. The thing is, I didn't find a way to open this file on ArcMap, but it's easily, you can open an ArcGIS Pro. So I'm sure that you all are using ArcGIS Pro. So the way to do this is not like drag and drop, like the way that we did with shapefiles. So I have to go in ArcMap here, and I will go to map, and then in map, let's say I'm gonna start a new folder, like you open ArcMap, and then you will have a map like this. And then I will go to map, and then there is add data. In add data, I'm gonna go where I download this folder. So here it's called the NSI G package. When I double click on this folder, it's gonna show a folder inside. The thing is, if you double click on the folder on the desktop, it's not gonna open. So you have to double click on it in the GIS or in the ArchiMap opener, and then when you click, it's gonna say main NSI. So when you click on main NSI and hit OK, so it's gonna show you this this point. So look at this. Zoom out on Texas, and then it's gonna show you. It's gonna load the buildings. It's gonna take some time. I'm not gonna load it, take all our time, but it's gonna start loading all the building little by little. I'm not sure. Maybe it's gonna take 15 minutes or something until it loads all the buildings. But the thing is, I don't want all the buildings of Texas. I'm not gonna do analysis and study for the entire Texas. So what should I do so that I can save my time? Maybe I turn off this layer, the layer that has the buildings, and then I try to find a shapefile that gives me the boundary of the city that I'm dealing with. I'm dealing with, I don't know, Galveston City. So I try to find online a polygon that shows me the boundary of Galveston City. If right now we are trying to deal with Nueces County, so I'm gonna try to find a shapefile for Nueces County. So you can either do it online, and actually there is, still taking time to load, but yeah. Here, like this is, I'm gonna give you a folder or a shapefile that has all the US counties as a polygon. So let's say, can open this one. Not Nueces County. It's called US counties. So the next step is to download the data of the county that we are interested in. And for example, I have the shapefile of the boundary of Nueces County. So I have like a polygon, and I'm gonna drag and drop, or you can load the data in whatever way that you like. I'm gonna put it here. So the next step is, like, let's say that we loaded the file that we got from the National Structure Inventory, and we have the boundary of the area that we are interested in. There is something on ArcGIS map that we can do. It's called the extraction. We extract the data of the county of interest based on the boundary that we have of any city. Like, let's say you pick San Antonio, Texas, or El Paso, Texas, or whatever city. You need to have a shapefile that shows you the boundary of the city that you are dealing with. And take this shapefile and the data that we got from the National Structure Inventory, and there's something up there, like, it's gonna show up in a little bit. It's called select. And when we select this data, we select, and the selection is gonna ask you for two folders. What is the main folder that you wanna select from? And what is the second folder that is the boundary of your selection? So once you give GIS these two folders, it's gonna do this. It's gonna check all the buildings within this boundary and select them, just select them, because that's a selection option. And once they are selected, we are gonna go to export the data that is selected. And now we are gonna have only the data of the buildings inside this area. So I'm gonna come here. This is the boundary of the Nueces County. And if I go to map, you will find something here. It's called select. Select number one is just regular selection, like you can click on this and select. Number two, which is the one that we need, is select by attributes. And there's something called select by location. We are gonna take the one is select by location. Too much time. Okay, so number one is asking you for the input features, and then ask you about how you are gonna select. I wanna select the relationship is intersect, and the selecting features is this. So in the first one, the input features, we put all the data that we got from the National Structure Inventory. All the buildings, like once you open, do you guys remember the file that called main NSI that was there? So we're gonna put this folder. It has like 10 million buildings. We only need the buildings that are in this zone. So I'm gonna give him the input, and then I'm asking, select the data that intersect with the selecting feature, which is this shapefile. So you give it two shapefiles, and then you hit apply. I'm not gonna load the file again because it's gonna take a lot of time to load, and this process might take some time because it's navigating the whole millions of buildings and see who's intersecting with this. It's like an if statement. If it's inside or outside, if inside or outside. So you give it 0 and 1 and you check them one by one. So, and once it's done, it's gonna select the building inside here. Once they are selected, you export them out, and only you are gonna have a shape file for the building within this area. And this shape file, I have it already done, and it's gonna be when I selected and extracted these buildings, this is the file that I got. It was something like this. So that's the data from the National Structure Inventory, something like this. Has the occupancy, has everything is loaded here. And also, for the flood depth, let's ignore this one for now. The thing is, it's gonna have the data, the last column is the ground elevation. There's no flood depths, it doesn't give you a flood depth. That's something that I did after, like post-processing with a hazard map, all right? Okay, so we have all this data. So the thing is, it doesn't tell me right away what is the building archetype. So first, I want to create a folder that has building archetype here, not a folder, a field that has the building archetype. So I'm gonna give you something that's called a mapping algorithm. This mapping algorithm, it's a MATLAB code. It's gonna read this shape file of the buildings. It's gonna read all these buildings and gonna extract some data from here. Like it's gonna extract the building, as we said, the building type, commercial, residential, whatever, the foundation type, and the number of stories. It's gonna get these three fields and gonna make if statement. So if this building, residential, is it on crawl space foundation, is it 2-story, assign archetype 3. Is this building commercial? What is the size of this building? There is some functions that is run inside this mapping algorithm to know how these buildings are matching the 15 building archetype. So let me show you how this could look like. I'm gonna go through it very quick, and since you are gonna use it, I'm gonna give it to you. You're not gonna write it. So yeah, it's called building mapping. So for the building mapping, it reads the shape file of the community of interest. Like right now I have Santa Cruz, maybe you change it to Nueces County buildings, whatever the name of the shape file, and make sure that this mapping algorithm is in the same folder with the shape file. The MATLAB code and the shape file, they need to be together. And from the shape file, I'm extracting this data. You see what data did I extract? Can you guys recognize any of the data here? Look, I have number 1, the occupancy, number of stories, foundation type, foundation height, ground elevation, building value, area. Maybe some of these I'm not. Oh yeah, I'm not sure if I'm gonna need the value of the structure, the content, because I'm not doing loss analysis. But I have the square footage because for business building, I have big ones, I have small ones, so everyone has different type. And then I'm doing mapping for flood and wind archetypes. I map what these buildings match, each one of the wind and the flood archetypes, okay? All right, so, and then I made for loop here, and I'm going through them from building number 1 until all the buildings, until the list of all the buildings. And I'm checking what is the occupancy type. If the occupancy type is agriculture, assign these archetypes. If it's commercial, these ones is the hazardous occupancy, and they are in this data. Look here. I have this one's the occupancy type in the shape file. Commercial 1, commercial 2. If you go on Google and search hazardous building occupancy, hazardous has 33 different occupancies. Every one of these has description. If you open the hazardous documentation for these archetypes, it's going to describe you what is each one of these means. What is commercial 1? What is residential 1 is? What is commercial 4? It's going to tell you, oh, this is a heavy industrial building. This is a light industrial building. So they have description for each one. And based on each description, I try to find out what these archetypes match in my archetypes. So that's what I try to do here in this MATLAB code. So, like you see, I try to match number 1, the occupancy, and I start assigning the archetypes, either wind or either the flood archetype. Then I did this for all the 33 different occupancies. There is some occupancy. The thing is, look at this. We have hazardous had 33 building archetypes or building occupancies, but I only have 15. So definitely, maybe industrial 1, like they have different types of industrial buildings, and I only have 2. So I have to find out which one of the 10 industrial buildings match my 2. So maybe 5 of them match 1 and 5 of them match 2. So find that some, like industrial 2, 3, and 4, 5, and 6, they are all gonna be one archetype, okay? All right, so, and I did this, so this is just a simple code. It's all if statements, and then I start to matching, I believe, the foundation, and the number of stories, and all of that. And once I matched all of them, so it's just one for loop to do the process for every building, and some conditions, if statements. And after I said, like, if this and this and that, match this, assign this. That's what is the if statements do. And at the end, once I did this and I did all the matching, I need to write a new shapefile that has the new archetype. And that's what I did here. That's what this function is doing. Bmap, like the new shapefile, I'm gonna map point to the archetype, to the shapefile S, because I define the shapefile here at the top. It's called S. That's the old shapefile. What I'm gonna do is I'm gonna map new fields to this shapefile. So I'm gonna map points to the S, and I want you to add to this mapped folder a field that's called W archetype, and another field is called F archetype. So we are gonna add 2 new fields to this shapefile, okay? And then write a new shapefile and call it Santa Cruz or Nueces County Buildings Mapped, okay? So once you do this process, it's not gonna take that long. You're gonna have a new shapefile. It's gonna be something, I have it here, it's called Nueces County Buildings Map. And then once it's done, you drag and drop and put it here. So the new shapefile is gonna be the same like the old one, but it's the only difference is it has 2 new fields. One of them it's called F archetype, and one of them it's called wind archetypes. That is the only difference. So what we have done right now, we have a shapefile that has buildings with a bunch of information, but we need to use this information to find what is the building archetype. So we take this shapefile as an input to a code, and we run this code, and we got a new one with the new data. So let's see what is inside this data. All right, I'm gonna close this. I'm gonna open the Nueces County Buildings Map and look at the attribute table. Now I'll go all the way to the end. Okay, so I want you to only look until F archetype. This data After you run, it's not gonna find, I did this a while after I had got this, I tried to do some processing on the data. But when you get the data, you will find a wind archetype and a flood archetype, something like this. Every building is gonna have a number. Wind archetypes are from 1 to are 19 archetypes. So you'll find some buildings that are archetype 18. The flood archetypes are 15. So the maximum number that you will find here is 15. Okay. All right. By the way, just to know, there's some archetypes that are not in my archetype. Like I don't have a high, like as I said before, I don't have multi-story building, like 10-story, 20-story, or something. So we make assumption that this archetype is gonna have one. The thing is, if I give it different number, like let's say, oh, because I don't have this archetype, I don't have like a high-rise building or a tall building in my archetype, I'm gonna give it 0 because it's not there. When you run your MATLAB codes, you are gonna get error. Okay, so I make an assumption it's gonna take one, like archetype 1 or something. Right, that's one thing that I have done. All right, so I'm gonna get these two. Right now, I know the archetype of each building. The second step, I wanna know how much flood depths every building is gonna have. So what I'm gonna do, I'm gonna try to find out somehow to get the 100-year flood hazard map for Nueces County, okay? Maybe you can use other hazard maps. I'm gonna give you all the hazard maps that you're gonna use. You're not gonna develop a hazard map in this class. So I'm gonna go here and get the hazard map. Okay, I'm gonna actually add data. You can add data either drag and drop, and some data you cannot drag and drop them, so you have to add them here from the add data. The geo packages, the geo database, all these you have to add them. Okay, so this is a geodatabase file, has some 100-year and 50-year events for Nueces County and Santa Cruz County. This data actually was downloaded from a website called Climber. Climber provide data, hazard map data you might use in the future if you want. So what I'm gonna do, I'm gonna use one of the 100-year event that they have for a 100-year event. So they have something that's called historical data and mid-century data. So the historical is like the regular 100-year event, a 100-year event that can happen any year from now until 100 years. They have something that's called the mid-century. That means what is the probability of a 100-year event to happen by 2050? Okay, so they have the data in a different way. But anyway, I'm gonna give you the hazard map, but let's say I'm gonna pick this one, and I'm gonna say okay, and this hazard map is gonna load here. So I'm showing right now all the process to do damage and vulnerability analysis, from the basics, how we develop the fragility, where it came from, and then how to download the data, buildings data, how to get the hazard data, and then how to get them both together, and then how to extract the flood depths. We did this before. Do you guys remember when we have a wind speed and we have buildings and we extracted the wind speed at each building? This is the same thing, extracting the flood depth at each building. So what I did, I loaded the hazard map, and as you can see, the hazard map starts from 0 up to 15 foot. This is in foot. So I'm gonna take this hazard map, and I have my buildings points. Do you guys remember how can I get the flood depths at each point? What did I do? I extract multi-value to point, or extract value to point, and I get the value of the flood depths at each point. But make sure our fragilities are in meter, and the flood here is in foot, so I have to convert from foot to meter, okay? All right, so, and I can see here actually the hazard map, it's black and white. Let's actually unload all these points so that we can see. It takes some time. I can actually change the color if it's gonna make it more comfortable to you. I'm gonna make it blue. And in this blue color, it makes actually the darker blue is the bigger, like the lighter blue is the high number. So I'm gonna mirror this color. Click here. I'm gonna click on this mirror, so it makes the darker blue the higher depth. So right now the darker blue is the lower depths. So what I'm trying to do right now is to swap them. It makes sense. All right, so right now the darker blue is the higher depth, and this is actually how the coastal flood, the 100-year coastal flood hazard map for Nueces County look like. And then if I want to zoom in just to have idea how it looks like, this is how the hazard map look like. Sounds like I'm gonna need next lecture to continue on this so that we don't have a separation, and then maybe on Tuesday next week we can write these codes together, like in the class, right? Okay, so next step is, until this map loads, I'm gonna use the extraction tool to get the flood depths. And by the way, I'm gonna get the flood depths in foot, as I told you. And the thing is, I wanna make sure that I'm a mid-century, because there's some depths are historical. So right now, wanna find out what is the flood depths to a 100-year event to happen until 250. 250 is the mid-century of the 20, in the century, that are we in the 21st century, right? So in the 21st century, so that's the event. But if it's a historical, that means until 2100. So that's the difference, okay? All right, whatever, like mid-century, we have a hazard map and we need to get the flood depths and we need to find the damage, either a 100-year or 200-year event, so it doesn't matter. Okay, so I have this hazard map, and these are the building points that I have if you wanna see how they look like on this map. So find some building actually are in the flood zone, and some building might not be flooded, like maybe here, and this is gonna show up in the mainland, because this Nueces County is a little bit special. It has an island, and it has a mainland, and there's a bridge between them. And the mainland is a little bit protected by the island. Like the island is the one that gets flooded and take most of the flood, and the flood doesn't make it to the mainland. It makes it through the tributaries or the rivers that they have around the rivers, but other than that, they don't get that much flooding. All right, so next step, I'm gonna go like search for how can I extract data. So I'm gonna write here, extract. And once I put extract, it should show up extract multi-values. Here, extract multi-values to points. gonna drag and drop the input features, the points that I want to extract at, and let it like a few seconds until it loads, and then I'm gonna drag and drop. I don't have actually drag and drop. Maybe you drop down here and collect the hazard map, and once it's loaded, you can name actually the folder here, but make sure when you name the field, you name it different names from the names that I have here. So I have here, let's say, I'm gonna say depth foot 1, because I already have something else, and then I'm gonna run. So basically the analysis that runs in the background, I believe it's kind of like a for loop for each building, and then see how each building is matching on each pixel, and what is the pixel value, and assign the pixel value that the building are intersecting with to the new field that we are going to have here. So, and here's it shows you how many percentages. That the extraction was complete, and it gives you some warning because there's some buildings have -999. Do you guys know what is the -9s? Here. So it gives you negative because there is no pixel value at these points, so it gives negative value. If you have a value, it's gonna put the number, but if you don't, it's gonna put -99. And we had this issue before, and I told you how to make them 0. You select them alone, and you assign 0 to these values, and then get back. So I'm not gonna do it right now. What I'm gonna do, I'm gonna check what depths is that we have here. Like I'm gonna check what is the maximum depth. So I'm gonna click on the top of the field, and it's gonna arrange them from the lowest to the highest. Then I'm gonna double click one more time to arrange them from the highest to the lowest. So it's arranging them right now. So it sounds like, look at this. I have here the depths mid-century. Thing is somehow these building has a flood depth, but these buildings, oh yeah, here, they are matching. Look at this. And this, they are matching. I believe these ones work for another event, the other one, the historical. But this one is having all the data that we have here, the depths and foot. And the second step, I convert them to meter. So how to convert them to meter? It's an easy step, we have done it before. You create a new field and name it, rather than depth foot, name it depth meter, and then you make the value of the new field equal to the value of the old field multiplied by the conversion from feet to meter, which is like around, you divide by like 3 or something, all right? So you find the exact number, the one that you should use, and this number is gonna give you this number because this one is the one that we need. Or you can keep it foot, and when we come to the MATLAB code and extract the value of the flood depths, you convert them in the MATLAB. So you either convert them here, or you either convert them in the MATLAB code. So that's number one. We got the flood depths, all right? But the thing is the verse flow elevation. But for the verse flow elevation, maybe you can do some stuff here, like you can find, if you wanna find the flood depths measured from the ground, that's it. either in foot or in meter, because that's the flood depth measured from the ground. If you want to find the flood depths measured from the FFE, we can do this analysis here, because we already have the ground elevations here. This is the ground elevations. And we have the foundation height. If we have the foundation height and we have the ground elevation, we can say, let me show you what is the foundation height that we have here. So if we go all the way back, somewhere here, yeah, here, the foundation height, and I believe it is in foot. And if we are not sure about it, we can go to the National Structure Inventory documentation. Let's go to the field that has the foundation height. Yeah, here. Describe the foundation height of the structure in feet from the ground elevation. So the values are in feet, so we are sure. So the thing is, I can convert, or I can keep it, and I use the ground elevation in foot, this value, and I plus them together, so you have the versus floor elevation measured from the ground. Then you can find what is the flood depth measured from, like we spent like a lecture talking about these elevations. So you can make all this analysis here and try to find what is the flood depth measured from the ground, what is the flood depth measured from the FF. All right, so we have all this here. Next step is, how can I take this file? This file is ready. This file has all the building archetypes. This file has the flood depth. All what I want to do is, I want to merge this archetype with my fragilities and say for each building, like building number 1, you have the flood depths and you have the archetype. Since you have the archetype, take the fragility that match the archetype and go in the flood depth here and tell me what is the exceedance probability of each one of these archetypes. Okay, so let's say this is building archetype 4. So in MATLAB code, I'm gonna try to design a MATLAB code so it can read what is the archetype of each building. So once it reads 4, it's gonna pick fragilities for archetype 4, and then it's gonna read then the flood depth, this depth, and goes here and then tell me what is the exceedance probability of each one of these damages stated. Once you finish this archetype, go to the next one, building number 3 or whatever, like building number 37 is archetype 2. Pick archetype 2 and its fragility and go with this flood depth and get what is the exceedance probability of each damages state. So that's what is exactly what we want to do. So to do this, you have to start a new MATLAB code. You have to read first. Do you guys remember the fragility parameters, the 15 one, the table? I have to read this table, and I have to prepare MATLAB to generate the fragility, this from the table. That's number 1. Once I do this, I read this shapefile, and I extract the data that I want. What the data that I want? I want the flood depths, I want the flood archetype, I want the building value because I want to convert the damage to losses. I read the versus floor elevation, I read the foundation height, and once I read those, I prepare the data to do the damage analysis, okay? So I'm gonna give you an overview what we are gonna do next time. So here is that MATLAB code that we wanna do next time. This one. Let's see what is in this file. I'm gonna go through it next time one step by step, but I'm gonna show you the chunks that we need to develop. Number 1 is I want to so this one, look at chunk number 1. I'm reading a bunch of Excel files, but the most importantly that I'm reading is the fragility parameters, the 15 building archetypes parameters that I showed to you. And if I open this Excel file, look at this. Fragility parameters, like if I open this one, it's gonna take some time. And the second one has the cost ratios. If you guys remember, we have at some point to convert the damage into losses. So basically, I give the software, yeah, here it opens. Can you see? This is the parameters that I have. Like, this is for damage state 0, so we only have archetype 1 and 3. And this is for each one of the archetypes. So we read this parameters. I'm gonna close this file. And then I have, I'm gonna tell you what is the other ones, but I'm reading some Excel sheets that can convert the damage to money. And then from this Excel sheet, I'm arranging them into matrices so that MATLAB can read them easily for each archetype. I'm gonna tell you exactly what is the archetype replacement cost. And then the second one, I'm reading the parameters. I read the Excel sheet, but I wanna arrange the lambda and xc for each parameter. So here, I'm reading mu, which is the lambda, and sigma, which is the xc, for each archetype and for each damage state, the table that I just showed to you. So I'm extracting the data for the damage state load normal parameters. So I have the mu for damage state 0, and yeah, I'm just arranging them. And this is the sigmas, like the damage state parameter number 2. And then I'm gonna show you how I'm gonna use them. So I'm just putting this Excel sheet, the parameters, like actually let's read this. So I'm reading the Excel sheets. And what I'm doing here, I'm just arranging them in a matrix. I put all the damage state 0 in a matrix, and I made a matrix of mu that has mu for damage state 1, 2, 3, and 4. Like, I'm gonna run this code. I'm gonna run this one as well. And when this one is run, at the end I'm gonna have, look at this, I'm gonna have a mu of each damage state. Like if I put this one, I open this one, it has mu of damage state 0 for all the archetypes. And if I open damage state 1, it has mu for all the archetypes. And the one that has mu, it's mu for all archetypes, from archetype 1 to 15, and for damage state 1 to 5. That's all the mu's. I put them in one matrix, and I have sigma all in one matrix for all archetypes. This is, I put them everyone separately so I can easily use them. The thing is, when I read them in the shapefile, each one alone is not easy, but if every one in one separate matrix, I have mu and I have sigma separately, I can use them easily in MATLAB. And then this for loop actually generate the points. Like right now, this function, it's called load normal CDF. It used the mu and sigma and flood depths and tells you what is the exceedance probability. So basically, I asked MATLAB with this mu and sigma of this line, I give you a 1000 value of the flood depths, try to calculate the exceedance probability. So that's what this function do. So I'm saying for archetype 1 to 15, for damage state from 2 to 5. 2 actually, I have 5 damage state. But number 1 is a little bit special. It's only for 2 archetypes. So that's why I left it alone. And I started from the next one. And I said, for all the lengths of depths, as like from depths equal to 0, 0.01, 0.02, up to 10 meter, calculate what is the exceedance probability. I give you the depths, and I give you the mu, and I give you the sigma. Try to find the second point y so that I can draw the curve. And then I did like here, look at this. This is a 3D matrix. What this 3D matrix has? It has for every flood depth, for every archetype, for every damage state has a value, okay? So right now I have one matrix that has all the numbers that can draw the fragilities for all the archetypes at all the flood depths for all the damage states, okay? So that's why for loops save a lot of time doing all these calculations. Like I did a nested for loop that goes archetype by archetype, damage state by damage state, and calculate the values or the points that allows us to draw this curve. And look at this, if we want to draw them, this is how I plotted them. Like I'm gonna click, this is the one that plot the fragility. So it's gonna go then figure by figure and draw. By the way, this is the fitted fragility, not the raw one, okay? Why it's fitted? Because we use the mu and sigma to get numbers. Like basically that's what log CDF do. Like I have a log CDF function. You give this log CDF the lambda and XC of each curve. This one has lambda and XC, this one has lambda and XC. All right, this is for damage state 1, 2, 3, and 4. All right, and you give it flood depth. You need to calculate at what flood depths. If you want to calculate just 5 points to draw the curve, give me these 5 points. Like flood depths 1, 2, 3, 4, 5, whatever. So you give it a vector, and then the output from this function is going to calculate the exceedance probability. So here you have the depth, and here you have the exceedance probability. So once you have the depth and you have the exceedance probability for all the damage states, you can draw them like this. Can you see? That's what this function did. So I will have here archetype 3, I have archetype 1, 15, all the archetypes. Okay? So right now, I have my fragilities ready to do the damage analysis. All what I'm doing right now, preparing for the damage analysis. So I made the fragilities ready, red, like all what I need to do right now. The thing is, these fragilities, when they are drawn at a specific values of the depths. But let's say, what if you have a building that has a flood depth of 4.0692? So what we do is interpolation. So we give the new number of the flood depth, and we ask MATLAB, interpolate on this curve. So I give you the interpolation function, the curve that is going to interpolate in, and go at this flood depth and interpolate for the new value of the exceedance probability, okay? All right, so right now we stopped at reading the fragility functions. Next time we're going to continue after this how we can use these fragilities to get damage. And next week we're going to have hands-on MATLAB. All right, see you guys next time.